All right. All right, let's start with this, Tony. F prime is the derivative. We have found the derivative, all right? We know that anytime we want to find the tangent line, all right, going back, anytime we want to find the tangent line, we've been pulling point Q back to point P, all right? And this has been in the homework over and over and over. That's stuff that you should be doing, all right? All right, A plus H, A, F of A plus H. Hey, Tony, listen up, listen up. Do you see the yellow line is going to have a slope of A of A plus H minus F of A all over H? Rise over run, right? Algebra 1 time. The yellow line slope is this.
So, to be sure, A is the point and H is the
Distance to the next one. Yep. So that is the slope of the yellow line, but I don't want the yellow line. I want the instantaneous slope. I want the slope of this purple line at P. So you send Q back by making H go to 0. And you take the limit. Okay, and that's why we practice limits so much, so we could do derivatives. All right? So you give me a function here, and I just showed you on the graph that it was smooth and you can take tangent lines. So there has to be a way to create the function. So what I have to do now, and I don't need any of this, okay, Tony? This is just the basic instruction. So I get rid of this. And I can start by, hey, f prime of x, because it asks you to find f prime, and I'm going to do it of x, is equal to the limit as h goes to 0. And instead of a, I can have the first point be any letter I want, right? A, B, C. How about we make it x? Well, now it's just function notation time. Now, is this a disaster, guys? If you've been doing your homework, you should recognize this is going to be a disaster. It's going to need common denominators. It's going to be a lot of work. Yes? No? You know how to do the shortcut yet? No. No. Well, not this time. Sign's different. Come on, the sign's different this time, right? All right, everybody, let's be careful here. Tony, this is one thing you've been kind of, I just wrote f of x plus h. I put x plus h into the red function. There it is. Minus, now I'll do f of x, which is just the function, all over h. This is f of x plus h. This is f of x. H is still on the bottom. Problem is we have to, number one, expand or get to a single term in the numerator. We never ever expand the bottom, but right now h is by itself. So I have to get a common denominator. Does everybody agree that I can drop? Yep. Does everybody agree I can distribute the negative here and the positive in the bottom and get to this step? And I can write 2 plus x plus h, right? And I can write over here 2 plus x. Up top, I can write 1 minus x minus h. I'm going to put that in parentheses, and you'll see why in a second. And over here, I still have 1 minus x, right? That's still all over h. Now it's algebra time. And one of my tricks, I'll do it in red. I like to extend the line. These are multiplied, right? Yeah.
Why is the 2 and 1 separate? Like, we're going to get it right.
Where?
For the 1 minus x minus h, why is the 1 and 2 separate?
Because they're not x, they're the numbers. You're just
Right,
replacing.
well, I'm saying, okay, so you brought it down so it's 1 minus, then parentheses x plus h. And you're distributing it in, right?
Yep.
It's still the same.
It's still the same. I just now have it as a single term. I put these parentheses around it.
Okay.
All right, you'll have to come in.
Especially with the top one, do that negative distributive.
No, he doesn't.
Maybe, okay, so it's got 1 minus x plus h. Now, in the Greek equation, he has 1 minus x minus h.
Yep. This negative sign right here, Tony, has to go to both terms.
Right.
Minus h. All right.
I'll figure it out some other time.
Yeah, you come in, you have to practice. All right. No, you won't. But anyway, here we go. Everybody, you get this. we learned yesterday that 1 over h, right? You can do it on the bottom as long as you do it on the top, which means the h will flip up, all right? So I can rewrite it here in red. And I'm going to have to give myself some space. I'm going to have to go back and get it larger. I can write it like this. H times 2 plus x plus h times 2 plus x. All right? That's the denominator. Right now, the bottom is still 0, right? If I plug 0 in for h, this is screwing me over. But I still can do now all this multiplying, Tony, is what we're going to do. And maybe so you see it, I'll write it out one more time. 1 minus x minus h times 2 plus x minus 1 minus x times 2 plus x plus h. You've done all that work, and yet you still have to expand the entire top. You have to expand the entire top, and everything that doesn't have an h better cancel. All right, because it is a function. We know it should do this. So I'm going to get down to 100%, get down to the bottom of the page, and start. Guys, 6 terms here. 6 terms here. All the signs on the second 6 have to change. These are the most common mistakes, right? Just a ton of work here. All right. So I get the limit as h goes to 0. I distribute the first one, and I get 1 times 2 plus x is 2 plus x. Negative x times 2 plus x is negative 2x minus x squared. Negative h times those is negative 2h minus xh. I will write in black above here so I can change the signs. 1 times all that stuff is just 2 plus x plus h. Negative x times those is negative 2x minus x squared minus xh. But then this sign has to distribute to all those terms. Again, algebra galore, right? Minus 2 minus x minus h plus 2x minus x squared minus xh. You got cut off. All right. Yeah, all over still h times 2 plus x plus h times 2 plus x. And what's plus x squared plus x. Yeah, you know what? I'd have caught it when I started canceling that I made a math mistake. All right, here we go. It should work. Let's see. Plus 2 minus 2 plus x minus x. Negative 2x, positive 2x, negative x squared, positive x squared. I get lucky this time. Negative xh, positive xh. And I'm left with just, one term. Negative 2h. It has an h. Oh, minus an h. Thank you. So negative 3h. You guys agree? Oh, I had to check. Yep. Minus 3h. You guys see it? So the top becomes that. Now the h cancels, and that's what we're after. Because the second I do that, I can now plug 0 in for h. And this becomes negative 3 over 2 plus x quantity squared. And we just found f prime of x. And I can't stress enough, you're going to have to practice these. They are ugly. Even once you learn the shortcut, sometimes I'll ask you to do definition of derivative, prove you can do it. All right? It is on the AP that way. All right? That is the derivative function for this. So then, you remember we were looking at the graph originally. If I go back up and pull the graph out, you might say, well, what's happening at 0? 0 is an easy number, right? At 0, it goes through half. So you look at 0. What's the slope of the tangent line at 0? You put 0 in. F prime of 0. It's just an evaluation problem. I think it's negative 3/4. So the slope of that line is not 45. It's a little shallow. And it's negative. And that is the slope of the tangent line at 0. If I want to find it at 1, Tony, I can simply plug it in. F prime of 1. 2 plus 1 is 3. 3 squared is 9. Negative 3/9 is negative 1/3. Notice how quickly it's changing as we get to the right. It's already gone. It's less than half already, right? Just by moving 1. Think about what happens at 10. It's negative 3 over 144. It's almost 0. It flattens out because the curve flattens out. All right? And it tells us what's happened. All right? That's going to be the big thing going forward. Again, anytime we have derivative, it falls to that definition of pulling point Q back to P. Now, a couple people, Allie, I'll pick on you because you seem like a memorizer to me. Up at Albany, if she's still awake. can get away, guys, with you can't get away with simply memorizing this formula. This is the formula, right? If you memorize this, you're golden. You are. It is the formula. The problem I have is that later on when we do applied problems, you'll struggle when we start moving stuff around. It's best to have the picture in your mind, the graph, which, seriously, I've drawn it probably 40 times, maybe 45. This is the derivative. Boom. You want f prime a smiley face instead of x? Sure, go right ahead. That means you just change I don't care what variable. Does everybody agree with that? I don't care what variable. And I also don't care what variable in the bottom. Could I do this? It's a little confusing because we've been saving A, but I don't care what the distance traveled is. And sometimes instead of A, they call this delta x. You start at x and you go some delta x to the right, right? Change in x. Doesn't matter. You just got to recognize the black here and this are the same exact thing, so you know they're derivatives of each other. They're a derivative. And I shouldn't even have to show you that. You should just be able to see this and say, yep, that's a derivative. That's a derivative. All right? And we'll work on that skill. It takes practice. All right? Now, when are you going to be good at this? We're going to show the shortcut probably tomorrow or Monday.
Really?
Yep. So listen. Yep, and listen, once you get the shortcut, Cole, I'll tell you this right now. On the test, I will demand you do it longhand. And you'll know what the right answer is, and I hate grading the first test, because I will go through step by step and make sure you don't cheat.
Well, I'm running through things myself, and I'd be 11ers for it.
That would help. Excellent. I am an ogre about that. These guys here, Juda will tell you, I am just, all right.
Hey, speaking of labeling, like, what do I need to label stuff?
Why?
No, what? Like, what kind of things do you label?
All right, so like in the textbook, if I ask you on a test to do this, and you know the answer is 7, and I put a big line over here, you either got to cheat and put an arrow here and go equals 7 over here, or on the line, anytime you write stuff, you have to rewrite the whole limit. You have to rewrite the whole limit. You have to label your x and y axes. If I tell you to sketch a graph, and you sketch this, I will take 3 points for no labels.
Like, do I need to label, like, my little number?
No, don't care. Unless I said, I never, no. I want sketches. I don't want that much work. All right, everybody, if I tell you there's a limit, what does that mean to you? If there's a limit of a function, you know what? What do you need to do to prove it? Left and right hand are the same. You all agree? I mean, I've been trying to beat that down your heads. Because there are places where functions have no derivative. You think of a function where the left hand and where it exists, and the left hand and right hand limits aren't the same. You can picture a function where that would happen. You can think of a continuous function. I put my pen on the board. I label my axes. I put my pen on the board. Can we think of a way to draw a function? Obviously a line, that's continuous and has a derivative. Is there a way for me to hold my pen on the board and make it so there is the left hand and right hand won't be the same? Sine and cosine, you got the right idea, but it's gentle, right? So all the way along, that line can shift, right? Tangent lines can shift all the way along. How else could we do it? Square root's getting closer, but it's still smooth. Everybody, I call it give me the bird. All right, because actually I usually draw it the other way first. You guys ever do artwork like Mr. Anderson, stick people and birds? Everybody, take a look at the bird at point A. Does f of A exist? Sure, it's right there. But look at now, look at the left-hand limit coming in. Do you guys agree it's that green line at A? Look at the right-hand limit. What is it? It's that red line. I don't have to ask are they the same because the green line is negative. The red line is positive. All right? If I blow this up, all right, that means that the function itself would be defined at f of A, but I would tell you f prime of A, the derivative of A, is undefined because it is a limit. The hands have to be the same. And you might say, well, Anderson, what about if you get it real close, you can see what I mean. Come on. If I blow this up to gigantic size, 300%, we blow in, we can see right at the point here, if I move these lines off, if I get a little bit off of A, all right, I just have to be a little bit off of A. And you can see right here, just a little off of A, we can see the right hand is this, and the left hand is that. They're the same, right? And likewise, just a little bit off A on the other side, I can see it's this and this, right? But when I get right to here, right at that little point, it's continuous, okay? But the limits on both hands are not the same. And that's one thing we're going to watch for. Have you noticed that every function we've been doing so far, guys, has been continuous functions? It's been root functions. It's been polynomials. It's been lines. Eventually, we're going to do trig. All right? Trig's ugly. Trig's ugly. Lots of trig. But we've stayed away from piecewise functions, haven't we? This is a piecewise function. To make this curve happen this way, this would have to be some sort of piecewise function. You notice we've stuck away from those. So as we move forward here, because we're running out of time, I just want to introduce the idea. If we understand that a derivative is a limit, then we would understand that the left hand and the right hand have to be the same. And thus, we would understand that sometimes it's possible for them not to be. All right? I can create all kinds of piecewise functions that have easy derivatives. Make that x equals 3. How about we make this 1, we'll make this negative 1. Guys, I think there's a derivative everywhere for this function, the way I've drawn it. I think it's 0 everywhere, except where? 3. And at 3, does it exist? No. Right? Slope of the tangent line. And we'll comb through those examples. And again, you can see, you say, why is there no derivative? Well, here, right? You might say, well, it's 0 and 0, but it's discontinuity. It has to be a continuous function, okay? The hands have to be the same. Oh, you guys don't care about geometry. You go back. You want to name vertical angles again? Oh, you know what? I can't do this well enough. Let's get a graph up. Because one of the things we want to be able to do is estimate slopes of tangent lines so we know where they're at. All right? All right. If I make this big, we could draw a function. Let's make it a continuous function with no vertical discontinuity, no birds, okay? Let's make it so it has a derivative everywhere. It's nice smooth curves as I draw, okay? We'll start there. There is no derivative at the end point because we don't know what's happening to the left of it. Oh, wow, isn't that pretty? And there's no derivative at the last point. Just to help you guys out, I'm going to number it. So the domain, do you guys agree, is -4 to 10? You guys agree the range is 2 to 7? Just for fun. Continuous function, right? No removables, no discontinuities of any sort, no jumps, no infinites. All right, I look at this graph and I say, okay, if you think you got this, what did I just ask you to? I want to know where x. I want the x values. What does f prime of x equals 0 mean? What's that? What am I asking for? What's it asking me? Two is one spot. Yeah, 2 is, how about 1? Yeah. He's, guys, and I know you can't see in the camera. Derek's sitting here going like this is his hand. You guys agree this tangent line is 0, right? We're looking anywhere where the tangent line is 0. So maybe 1, and maybe that goes all the way from 1/2, okay? 5 or 6, yeah, how about, yeah, somewhere in here. We'll call it 6. 1 and 6. Is there any others? No, I think that's it. Guys, those are the tangent lines where it's 0. The other thing I could do, right, is I could say, hey, where is f prime? Tell me what's the slope of f prime of 9. All right, so you got to go, now it's the other way, right? It's not asking to find a slope of 9. It's saying, go to 9 and tell me the tangent line slope. All right, so in my textbook, I go to 9. If you do it with a pencil, so we can erase it. Everybody, since it's a grid line, I'm not going to do rise over run. What do we know as long as the coordinates are the same? One space this way is one space this way. A 45-degree line is what? Slope of 1. Okay? That's about 1, isn't it? If you want to get really precise, maybe say it's 0.9, because maybe you think it's 40 degrees. A little less than, a little less, a little shallower. Is there any place where f prime is really high negative? One spot. What if I ask for f prime of -2.5? Go to -2.5. Go up. I'd say that's pretty negative. Now, if it's a test, maybe I'd actually measure it. Oh, let's see. It looks like I run all 3 here. No, yeah, 3, and it goes up 1, 2, 3, 4, 5, 6, 7. So maybe I say it's -7/3, 2 1/3. All right? Guys, the derivative will give us the slope of the tangent line. Now, if I knew the function, could I do the substitution to derive the function? The answer is yes, I could. Because this function is continuous. Has no verbs. Has no points where the tangent line is undefined left or right, all right? But that's a function, and again, continuous. A continuous function everywhere on the board, all right? Does it? Could I draw the graph of this function? Could I draw the graph of the derivative of f of x? I want a graph now, guys. This is the last thing we're going to talk about. 3 o'clock bell just went. I heard a watch. I'm going to graph f prime of x. Does everybody see that f prime of x, we agreed was 0 here, right? At 1. I'm doing it purple. And we agreed it was 0 here. We just agreed on that. Everybody, what's the slope over here? Positive or negative? Negative. In fact, we agreed up here it was like -2 point something, right? So here's -2 point something at 2.5. So maybe I have a dot here. All right? And it's kind of shallow at first, so maybe it does something like this. All right? It's continuous, all right? And this will take practice. All right. What do we know from here to here? Positive. In fact, it's about 1 here. Do you guys agree in the middle? So I'll put a dot at 1. Whoop. Then it's 0 for a while, or it's just barely negative, right? So maybe it goes under, and maybe it comes back. Maybe there's another 0 here. Otherwise, maybe you think it's 0 the whole way, and that's fine. You think it's 0 the whole way. And then what's it do? It gets positive. Like, maybe it's 1 here. Yeah, it's about 1. It gets to 1 and kind of hangs there. And maybe you think it goes faster. All right. There. We just graphed the derivative. That is hard to do, and I gotta believe that left a lot of you dizzy. But that is. Oh, that should be a 1, shouldn't it? You're right. Too high. There, how about that? Nope. I'm sorry. Yeah. There. Sketching derivatives is a lot of work. Alright? Especially when you don't have the function. That's what we're going to pick up tomorrow. That's what we're going to finish before the shortcut for Cole. Okay? I think it was Cole that asked. Sounded like his voice. Alright? Yeah, we'll survive. We're not having a test next week because it's Albany's homecoming. We are having a quiz Monday. I will go look at it right now so you know which lessons it's on. I got it written. Domain and range. Domain and range, even and odd. Alright. Graph and a line. Pretty straightforward quiz. Alright. And then we really start finally getting some heavy calculus stuff at. And then quiz 4 is when we start getting some heavy calculus stuff, guys. Alright? Where we start talking about, you guys do secant and tangent lines. We'll have to do some examples again. Define limits. Alright?
Is everything building up with limits?
Yes. Generally, everything falls back to limits. Because derivatives are limits and everything will go to derivatives. The truth is we are very, very, very interested in where derivatives are zero. Because it's decreasing and increasing, alright? So, everything's going to build on derivatives, and that's why, then they're limits, and that's why we spent so much time talking about it. Alright, guys, have a merry day. See you tomorrow, okay? Quiz Monday. Yes.
You guys put on all day?
We're at Barberville tonight.
Oh,
Are ya? Okay.
Maybe there won't be like a tornado there.
Yeah, maybe you won't have to sit in the locker room for 45 minutes like Juda did when we were up there in the middle of the game. Tornado watch or warning, and they shut us down in game 2. It was bad for Juda that night. We were hot and then we weren't.
Yeah, then they took it down.
So, all right, you guys have a good night.
Yeah, next week.
Here.
Laptop.
Appreciate you bringing it back.
That's a cool thing to know.
Right?
Yeah.
The quick brown fox jumps over the lazy dog uses every letter of the alphabet. I didn't know that. I was like looking at this like, oh my god, they're right.
Oh my god, that is quick brown
The quick brown fox jumped over the lazy
Keep
dog.
running. One of the things you're going to have to memorize, right?
They just repeat like T, H, and E are the only ones that like.
That's impressive that they're still.
It's uses everything. Oh, and then O is used 3 times.
By the way.
Usually hour.
Johnny?
Yeah, you guys go everywhere.
Just sleep.
I can't sleep.
I don't think I can.
I can't.
I
I
try.
I can't do it because I know what would happen if I did. That's the thing. Like I try not to. Like,
Are you telling me they would do things to you?
On the boys' track
Yeah.
and cross country bus, yeah, they would.
Yeah, because
Sleeps.
I'm a heavy sleeper. Sleeps on the bus. Very heavy sleeper.
Yeah.
Right.
Even for like math.
Oh shoot, we're still taping.
Sleeping, there's.
Oh. Gosh, I don't think I said anything in